ANSYS Simulation Lecture 20 Part 2 Transient Dynamics Direct Integration Method. For direct integration method, we simply drag transient structure and drop it on geometry and enter ANSYS mechanical interface. And the process is similar, except that we do not run the model analysis. So first of all, I'll connect the material with the geometry, and I'll take the default structural steel as the material. So for the third step, I'll update the mesh using default meshing size. And for the step 4, we will define the fixed support at the bottom surface and also apply a transient force on the X plane. So I will define the force acting on the X surface, the surface of the load, the direction of the load, the magnitude of the load, and time curve of the load. And I'll define a transient loading where the force is applied from 0 to 0.05 seconds, and it is released afterwards. So you can see from this time curve that the force is applied from 0 to 0.05 second, and the force is released afterwards, and the structure will undulate on its own. So this is the step 4. Make sure that the time curve of the force is defined. And then for the preparation of step 5, we need to define the time steps. The total time will be 1 second, and I'll turn off the auto time step function. And now I'll define a substeps, 200 substeps. And for the result, I'll get total deformation and equivalent stress. And also I will probe the deformation for a point here. Probe for a point here. And for total deformation. So this is the result that I am interested in. So now we'll solve for the 200 substeps. In the direct integration method, if you apply the load which is too large, or the number of steps of too small, the software will give you warning message or even error message. So if the force is very large, you need to use explicit dynamics instead of implicit dynamics. So you can see that the amplitude of this point remain the same, and it undulates back and forth. Right, so this is the result of the transient dynamics method, the direct integration method. And you can compare the direct integration method with the mode superposition method, and both are for transient dynamics. And for direct integration method, there are implicit dynamics and explicit dynamics. And this problem is the implicit dynamics, which is applicable for lower plastic deformation or lower force, lower deformation. For very, very high deformation or very fast ballistic impact, we need to use explicit dynamics module.